When the Hearing Health Foundation approached Lipreading Mom about doing a story about curing hearing loss, I admit I was skeptical. Is a cure really possible? And if it is, would it benefit those who have embraced their deafness? I have many friends who have been able to hear all their lives, and they lead very full lives. So why the need to change that? Lipreading Mom recently conducted an email interview with Shari Eberts, chairman of the Hearing Health Foundation SHHF Board of Directors, about FAS research into hearing loss. When did research into a hearing loss a circumflex cure first get support from the Hearing Health Foundation? FAS founder, Khalid Ramsey Baker, was steadfast in her support of funding for new technologies and treatments for hearing loss, despite objections and doubts from supporters and those in the industry. Because of that commitment, HHF has been a leader in driving new innovations and treatments for people with hearing loss for more than 50 years. This includes funding research that led to the development of cochlear implants and many of today's standard treatments for otosclerosis, abnormal bone growth in the ear, and ear infections. Today, HHF continues to support groundbreaking research in hearing through the search for a biological cure for hearing loss and tinnitus through its Hearing Restoration Project, HRP. HRP officially launched in 2011 and is currently funding 5 projects from its consortium scientists, but the initial discovery that led to the HRP came many years before. Many types of hearing loss result from damage to the delicate hair cells of the inner ear. Humans cannot regrow these cells, but in a game-changing breakthrough in 1987, HHF-funded scientists discovered that birds can. While studying how drugs that are known to cause hearing damage affect the tiny sensory cells in the ear, these scientists needed to permanently damage a chicken's hair cells. For 10 days, research assistants administered a common antibiotic, known to cause hearing loss, to laboratory chickens. On day 11 many of the hair cells were lost, and a few days later, even more were lost. Surprisingly, when the scientists looked 3 weeks later, almost all the hair cells had returned. They did not believe these results, so they did the experiment again and again. Sure enough, chickens can naturally regenerate their inner ear hair cells, restoring their hearing after damage. Our HRP consortium is the dream team of hair cell regeneration, comprising the best auditory scientists at leading institutions worldwide such as Harvard and Stanford. With more than 200 years of combined experience in hearing research, the HRP consortium publishes widely, over 400 published papers among them, and have well-established labs, receiving over 600 NIH grants combined. We have every confidence we have the right team in place, and the right model to accelerate the timeline to a cure. For years, scientific research has been conducted in relative isolation, one researcher or one institution working alone to tackle a major health issue. HHF developed the HRP consortium model to do things differently. Our HRP scientists work on research projects together, share their unpublished data and tools, and collaborate on the development and refinement of the PAS strategic research plan. The group meets biannually in person, monthly by conference call, and communicates frequently by email. This continual dialogue is helping to eliminate repetitive work across the team, saving time and research dollars, and most importantly, accelerating the timetable to a cure. Even though we are in the early stages of the research, we think it is very important that the public learn about our efforts. We want them to know that there is hope for a cure, and that there are researchers who consider curing hearing loss and tinnitus to be their life's most important work. We hope our marketing efforts will help bring attention to the issue, raise awareness of the prospects for a cure, and inspire other scientists and lay people to join us in our support of this important research, so that we can find the cure as soon as possible. But what about people with different forms of hearing loss? How can these research findings affect people born with hearing loss? People with late-in-life hearing loss. There are 2 broad forms of hearing loss. Conductive hearing loss is caused by any condition that blocks or impedes the conveyance of sound through the outer or middle ear. The result is a reduction in the sound intensity that reaches the cochlea. Common causes include ear infections, a perforation in the eardrum, or even build-up of earwax. Generally, conductive hearing loss can be treated with a complete or partial improvement in hearing. Sensorineural hearing loss commonly occurs due to an injury or degenerative change in the inner ear and is currently permanent. Damage to the hair cells in the inner ear is the most common type of sensorineural hearing loss. The Hearing Restoration Project is focused on the cure for sensorineural hearing loss through the regeneration of these damaged inner ear hair cells, and with it the regeneration of hearing. Most types of age-related hearing loss and noise-induced hearing loss are caused by damage to these hair cells, making the HRP research applicable to most types of acquired hearing loss. The amazing thing is that regeneration happens naturally and very robustly in almost all animals. Acircumflex mammals are the exception. This makes HHF and the researchers confident that we will find a way to stimulate this regeneration in mammals, including humans. While 10 years may seem like a long time, and it is for someone like myself who lives with hearing loss every day, it is realistically within my lifetime, and that gives me hope and excites me for the future. While we wait for the cure, we encourage people with hearing loss to seek treatment for the condition through hearing aids or other means, so that they can enjoy the highest quality of life possible, while they wait. What about tinnitus? How can these findings help the millions of people worldwide with ringing in their ears? With 90% of tinnitus, ringing in the ears, occurring with an underlying hearing loss, our cure for hearing loss is also likely to be a cure for tinnitus. In a recent article in Hearing Health magazine, FA's free quarterly publication on all things related to hearing loss, this topic was discussed in detail. Some of the high points are detailed below. There is certainly evidence that the restoration of hearing can alleviate tinnitus. For example, tinnitus can be induced by exposure to loud sounds that result in the temporary loss of hearing, which is experienced by many after attending a loud event like a rock concert. In most such cases, the tinnitus disappears as the hearing recovers. Another example is the response of patients for whom otosclerosis, an abnormal bone growth in the middle ear, has induced a conductive hearing loss. Many such patients with this hereditary condition experience tinnitus. However, when their hearing is restored through a surgical procedure, many report an improvement in tinnitus. Finally, there have been several reports that patients, after receiving a cochlear implant, experience a significant reduction in their tinnitus. Interestingly, in some cases this tinnitus suppression continues for several hours after the implant is turned off. Though the mechanism by which cochlear implants may suppress tinnitus is not clear, these observations all suggest that restoring function to the auditory system may be very helpful for tinnitus in a variety of ways. There may be skepticism about acircumflex curing GAD hearing loss. How would you respond to criticism toward curing hearing loss or deafness? For example, the deaf community has a strong cultural identity shaped by living with deafness. Some would argue that a person's deafness is what makes him/her unique, so why change it? Hearing Health Foundation respects everyone's individual choices and beliefs as relates to their hearing loss. For those interested in a biological cure, we are proud to be working on one.